Assalamualaikum warahmatullahi wabarakatuh. We will be explaining about Chapter 4 DC machines. There are 5 tasks. For me, Ahmad Khidir bin Hussein, 35 DSE 25FF 1052. I will explaining about task 1, which is about DC machine based operation. So what is DC machine? DC machine is an electrical device that works with direct current or DC. These machines are widely used in electrical system to convert energy from one form to another. DC machines can be divided into two main types, which are DC motor and DC generator. What is DC motor? So DC motor converts electrical energy into mechanical energy. This happens through the interaction between magnetic fields and electrical currents. When electric current flows through the motor, it interacts with the magnetic field inside the motor. Because of this interaction, a force is produced. This process follows the basic principle of electromagnetism. As a result, the electromagnetic fields create rotational motion, which causes the motor shaft to rotate. This rotation can then be used to drive machines or mechanical equipment. A DC motor can be found in electric fan. Next, DC generator. DC generator converts mechanical energy into electrical energy, which is direct current or DC electricity. This process works based on electromagnetic induction. When a conductor moves through a magnetic field, it cuts magnetic flux and produces an electromotive force or EMF. This induced EMF causes current to flow in the circuit. The direction of the induced current is determined using Fleming's right-hand rule. So in simple terms, when mechanical motion is applied to the generator, it produces electrical energy in the form of DC. DC generator can be found in battery charging system. So basically, both machines involve energy conversion, but they work in opposite directions. For the next task, we'll be explaining about DC machines component, which is by Adam.
Today, I will explain the main components of a DC machine. A DC machine can work as a motor or as a generator. Both have the same basic parts. So let's check it out for the first component, which is the armature. The armature is the rotating part of the machine. It is placed inside the magnetic field. It also made of laminated steel and contains windings. In a DC motor, the armature receives electrical energy and changes it into mechanical energy which makes the shaft rotate. Then, in a DC generator, the armature rotates because of mechanical input and produce electrical energy. So, the armature is the main part where energy conversion happens. So, for the next one, which is commutator. The commutator is connected to the armature winding, it is made of copper segments. Its function, very important in a generator, it changes the internal alternating voltage into direct current at the output. In a motor, it helps keep the rotation in one direction only. Without the commutator, the machine cannot produce a proper DC output. So for the third one, now the brush and springs. Brushes are made of carbon. They press against the commutator. Their job is to transfer current between the external circuit and the rotating armature. The spring push the brushes to make sure the contact is always good. If the brushes are worn out or sparking and also power loss, that can be happen. Last but not least, field poles and coils. Field poles are fixed inside the machine. They do not rotate. Their function is to produce and guide the magnetic field inside the machine. The magnetic field is necessary for the motor to produce torque or for the generator to produce a voltage. Around the field poles, we have field coils. Field coils are copper wires wound around the poles. When DC currents flow through them, a magnetic field is created. The strength of this magnetic field affects the performance of the machine. In conclusion, all components to work together. The armature converts energy, the commutator controls the current direction, the field poles and the field coils produce the magnetic field. So I think that is all for the DC machine components. Thank you so much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hafi Imran, and today I'm going to explain the types and application of DC motor. So on the first slide, that is today focus, I will explain the difference between stud, series, and compound in the terms of construction, characteristic and typical application. That is gonna be example of our everyday thing. So for the first type of DC motor is DC shunt motor. For the construction part, it is a field winding connected in parallel with armature. As you can see on the picture that I provide down here, it has a DC power supply, shutter field, and armature. And the characteristic is it has a constant speed, moderate starting turrets, and a good speed regulation. So for the next slide, I will explain the DC series motor. As you can see, it is a little bit different from the DC shunt motor. The construction of the DC series motor is field winding connected in series with armature. The characteristics are it has a very high starting torque, speed varies with load, and cannot run without load. Means if it doesn't have a load, it cannot move. For the daily application are crane, hoist, and electric trains. And for our last type of DC motors are DC compound motor. For the construction of this is combination of shunt and series field winding. The characteristic are very high starting torque. For the daily life application is elevators, press machine, and rolling mills. Now we are headed to the last slide, that is the comparison. As you can see, it is very clear and light as a day that the compound DC motor is better than series and shunt DC motor because it has a high starting torque, a better speed regulation, and it is used in heavy industrial application. So applying it into our marine engineering, we use a compound DC motor. That is from me, Hafi Imran. Thank you. And for our next topic, task 4. That the compound DC motor is better than series and shunt DC motor because it has a high starting torque, a better speed regulation, and it is used in heavy industrial application.
Hi, Assalamualaikum. My name is Muhammad Lutfi Hakimi. Now I want to explain about DC machine and work application of DC machine. The DC machine used to convert electrical energy into mechanical energy, which is known as DC motor. And the DC machine used to convert mechanical energy into electrical energy, which is known as DC generator. In manufacturing industry, DC machine, especially DC motor, are normally used to operate machine that require precise speed control, high starting torque, and the ability to handle high current or voltage demand. This means the motor can start with stronger power and can control the speed accurately depending on the machine need. DC provide a constant flow of electricity, so DC motor can deliver stable and controllable power. Because of that, they are ideal for application like conveyor belt, crane, and hoist, which are commonly used to move material or heavy load in factory. Next, transportation. Next is transportation system. DC machine are used in electrical train and electrical vehicle. They operate using direct current supply from battery or DC power system, which make them suitable for vehicle that use battery power. DC machine provide high starting torque, which is suitable for moving heavy load such as train. They also ensure smooth acceleration and better speed control, meaning the vehicle can move smoothly without sudden change in speed. Next, in marine application. DC machines are also used in marine applications such as ship and boat. They are used in electrical propulsion system, which help move the ship through the water. They are also applied in winches, crane, and anchor handling system, which are important for lifting heavy equipment on ship. DC machines are suitable for battery-based and onboard DC power system and help ensure smooth and precise speed control. Can also help reduce fuel consumption in hybrid marine system. Right, thank you.
Hi, for today I'm about to explain DC motor starting method. First, I will explain the starting method of a DC motor. When a DC motor starts, the back electromotive force or back EMF is 0. This causes very high starting current, and also high current can damage the armature winding. Therefore, a starter is used to limit the starting current. Common starter that are used is 3-point starter and also 4-point starter. Next is step-by-step operation. First, ensure power supply is off before connecting the motor. After that, connect the starter in series with the armature circuit. After that, turn on the DC power supply and then move the starter handle slowly to reduce resistance gradually. When the motor reaches normal speed, the resistance becomes zero and the motor runs normally. This prevents excessive starting current and protects the motor. Main speed control method. The way we control the speed is by armature voltage control, such as change the voltage supplied to the armature. Higher voltage, higher speed. Field flux control. Adjust the field current using a rheostat. Lower field current creates higher speed. And the third is armature resistance control. It adds resistance in series with armature. It creates more resistance and it reduces the speed. Summary for this is that the DC motor requires a starter to control high starting current. Proper starting current ensures motor safety and also longer lifespan for the DC motor. And third, the motor speed can be controlled using the armature voltage control, field flux control, and armature resistance control. This method allows the DC motors to be used in industrial machine, cranes, and electrical vehicles efficiently.